Hello everyone, welcome to your next lecture series. We'll be talking about standardized rates in this lecture. Basically, we'll be covering two methods of standardization, which is what is known as the direct method of standardization and what is the indirect method of standardization. Moving further. Yes, it would be good for you to watch this video before you go further in the lecture, because this gives you a good overview about the concept of standardization and direct and indirect methods of standardization. So it's a good introductory video for you to watch before you proceed. Alright, so now standardized rates. What are standardized rates? Standardized rates, they help you to compare both measures of morbidity and mortality between two populations. We have already covered measures of morbidity. We have also covered measures of mortality. Now standardized rates, they help you to compare measures of morbidity or mortality between two or more populations. Okay, so for instance, if you are comparing say the prevalence of obesity between males and females in Australia. So that is comparing a measure of morbidity. Morbidity, why? Because obesity is a chronic condition. You are examining the prevalence of obesity, which is morbidity, measure of morbidity in the Australian setup between males and females. So you're comparing two different populations, males and females, for a measure of morbidity, which is obesity. Now, if we take a second example where you are comparing say males and females within the Australian setting who are newly diagnosed of say cancer, alright, it could be say lung cancer or it could be say pancreatic cancer. So you are comparing males and females within the Australian setting for individuals who are newly diagnosed with pancreatic cancer, okay. So this is where you can say you are comparing incidence between two things, between two populations. Now you can similarly compare death rates, which could be say death rates in India versus death rates in Australia versus death rates in China in children who are under 5 years of age. Okay, so this is where you are comparing three populations, India, China, Australia, for infant mortality rate, and this could be for infants who are under 5 years of age. Okay, so yes, this is what it means, that you can compare measures of morbidity and mortality via standardized rates, and for two or more population. This standardized rates are different from crude mortality or morbidity rates. Why? Because they can adjust for a few confounding factors. Predominantly, they are adjusted for age and or gender. Alright, so you can say irrespective of age, you have say 70% of the population in Samoa who are suffering from type 2 diabetes versus say 40% population in Australia. Okay, so it could be say irrespective of age, it could be say irrespective of gender, and age particularly is used as a variable for adjustment when you are comparing and describing mortality between two populations. Okay, but yes, so the most commonly adjusted variables in standardized rates are age and or gender. Okay, and we'll be looking at examples as well. So now you have two main methods of standardization, which is your direct method of standardization versus your indirect method of standardization. What is direct method of standardization? Here you are comparing your population of interest, your sampled population, to a reference population. Alright, direct method of standardization is used when your sampled population or population of interest is of a very large sample size. Alright, for example, you are comparing cancer rate across countries, India, China, Australia, Britain, so on and so forth. Okay, so remember critical points. Direct method of standardization, you have your population of interest, your sampled population. it is compared to a reference population, and you're using this with a large sample size when your population of interest is of a larger sample size. When is indirect method of standardization used? Basically, indirect is used when direct cannot be used. Meaning, what would be the difference? When you do not have a reference population available. So, a very big difference between direct and indirect method of standardization is, in indirect method of standardization, you do not have a reference population available to compare your sample population of interest with. Okay? Then it is used when your population of interest or your sample population has a smaller sample size. Alright? And when you have a smaller sample size and you are comparing it to a reference population, this can increase your type 2 error. Alright? And that is why you do not want to do that. So, when you have a smaller population, that is when you use indirect method. When you do not have a reference population, that is when you use an indirect method. For example, comparing ACT to New South Wales, these are much smaller population in comparison to comparing say cancer rates between countries like India, China, Australia, so on and so forth. Okay. So, I hope the distinction is clear between these two, which is direct versus indirect method of standardization. So, yes, how are you to use it in practice? For you as a dietitian who may be in a dual position, you have to use this knowledge to interpret tables and graphs correctly. Alright, so we will be looking at, so for example, even in your say assessments, you may have a graph such as this one, and you may be asked to interpret this graph with specific questions correctly. Okay, so that is how you have to use this knowledge of standardization in correctly interpreting graphs and tables. Okay, so that is what is useful for you and important for you as a dietitian. Alright, so yep, as we have said, standardized rates, what does this mean? That these rates, standardization means you can compare data across populations. These population could be say males versus females, or it could be say ACT New South Wales interstate population, or it would be say countries where you're comparing countries. So, basically you can compare data with standardized rates. Comparison in statistics and in epidemiology, guys, is only meaningful and accurate if it is standardized to a certain degree. Okay, and over here when we say standardized, we mean we are adjusting it for certain variables. Alright, so we will look at the graph which we saw currently 2 minutes back. We'll be looking at that. It was difficult for me to fit everything in this slide, so I have given you the link to the research article from which I have taken this graph. Okay, so this graph is available in this research article if you want to go through the entire research article to make more meaning of this concept. And this is what the detail is, the detail of the graph that we will be looking at. So, your graph is in terms of bar charts, and what they have reported to you is age adjusted. Okay, so it is your graph is adjusted for age. So, when you say it is adjusted for age, meaning you can say irrespective of the age, XYZ things are happening in the population. Alright, so age is not a variable that will influence your results anymore because you have adjusted for that variable. Okay, so that is what it means in epidemiology and statistics. When you say adjusted for something, standardized for something, it means that variable is no longer influencing your research question. Okay, so yes, the graph which we will be looking at, it is in terms of bar charts, and you have say age adjusted, and it is reporting on incidence of what? Incidence of cancer, lung cancer in 2018. Okay, and it is comparing two populations, meaning males versus females. Okay, and it is reported in 100,000 person years. Alright, so now you know the concept of person years, that is incidence rate if you remember, and as I said, the unit of time could be years, it could be hours, it could be minutes, it could be weeks. Alright, so over here the incidence rate, the unit is in person years. So yes, this is how your research paper reports results, which is age standardized rates per 100,000 person years. Okay, and this is calculated via direct method of standardization. Why? Because they have compared the population, your population of interest, which is various countries, to the world standard population. Okay. So yes, this is how this information is important for you to use in real life practice as a research clinical dietitian, for instance. Okay, so now the question that we have to answer when we look at the graph is, and these are the sort of questions you can expect in your assessments, is among males and females, who has the highest incidence of lung cancer? Okay, so within males, which country has the highest incidence of lung cancer? Within females, who has the highest incidence of lung cancer? The answer over here is that after you adjust for age, Polynesian males and North American females have the highest incidence of lung cancer. And now you know incidence meaning new cases. They are newly diagnosed with lung cancer. And what was the year? In 2018. Okay. And remember, so if you see, this is the graph which is reported in the research paper. It is standardized for age, as it says over here. Okay. And if you look at more details in the method, it is said it is done via direct method of standardization, where all of these countries, this data is compared to a reference population. What is the reference population? The world standard population of incidences of lung cancer. Alright. So over here we said that Polynesian males, okay, so over here you have Polynesian males, which is 52.2, alright. So they have the highest incidence of lung cancer. And we said North American females. So you have North American females. Females are over here in pink, and that is the highest incidence of lung cancer among females. Okay. So basically for you, using this concept is very, very simple. You take this understanding and you interpret graphs correctly. That is all that you need to do as a research dietitian. But of course, there are some of you who could be interested to understand the underlying calculations which go within this, and this is what I want to share with you in the coming slide, just for your interest, for your knowledge, curiosity. It is not part of any assessment, but this is just to show you the underlying mathematics which goes on in calculating your standardized rates. It could be via direct or indirect method. Alright. So yep, so what I am showing you now, it is not part of any assessment or any quiz or anything which you are doing as part of the unit. It is just to advance your knowledge in research in epidemiology. Okay, so just bear with me, I will open my Excel sheet. So yep, you have the Excel sheet over here, and then I will just make this a little bit bigger so it is easier to see. So I'll be looking at my laptop screen, guys, so that's why it won't be, it will look like I'm not making eye contact with you, because the print is really tiny for me to read in the screen which is in front of me. So I'll be looking at my laptop to explain you this concept. Again, remember, this is not part of any assessment. This is only for students who are more interested to understand the underlying mathematics which goes behind the calculation of standardized rates. So the first one which I am looking at is the direct method of standardization. Alright. So now in my direct method of standardization, remember, direct method always has a population, a reference population. So and as I said, with mortality, with the concept of mortality, you generally adjust for age. Okay. So over here you have country A and you have country B. So these are the two populations which I am comparing, country A and country B, hypothetical example, and these are the age groups. Okay. And then these are the number of deaths which are there in country A, in country B, in each of these age groups. All the data which is there in grey color, this data, for example, is provided to me in governmental reports. Okay. So yep, I have the number of deaths which are there in country A and country B. What is the second column? The second column is population age specific death rate per thousand. Okay, so this is per thousand is what we have computed, where you have death rate, population specific death rate per thousand. So how many people say dying per thousand, like that. Alright, so this is the data which is available again from governmental reports. There is no calculation which is involved over here. Then you have this yellow color, this is what I have calculated, which is observed age specific death rate per 1000 person years. Now this is this column number D, this column D, that is my crude death rate. Okay, crude, it is not adjusted for age or anything at the moment. Okay, so this is the crude death rate. Alright, so now just going back again, so your country B was this a number of deaths, okay, in each of this age group. If you look at the total number of deaths, alright, over here you have 147, alright, over here you have 15,300, alright, and then if you look at these both numbers, you will you may think, oh, country A has more number of people dying compared to country B, okay, alright. So now this is your crude say understanding of the data. Alright, now what we do, we have in column E, we have the reference population. Okay, so what is my reference population? My reference population is country C. Okay, so this is hypothetical country C. Alright, and I have the death rate per again it is per 100,000. Alright, so this is per 1000, sorry. This is what I have for country C. Again, this is there, the data is given to me in governmental reports and I have this information. Now what I do is I calculate standardized rates, and guys, I have given you the formula over here how I have come to the say calculations. So when I calculate my crude death rate, which is my column number D, I do B divided by C. So column B divided by column C, which is number of deaths per the total population. It gives me the crude death rate, which is column B divided by column C gives me column D. Okay, that's how I have come to this understanding. Then you have column C, column E, which is your country C, which is your reference population. This information is already provided to you in some reports. Alright, and then you calculate your standardized rates. How do you calculate standardized rates? This is D into E. So you have your column D. What is your column D? Crude death rate, okay, which is multiplied by, you have your column C, which is your reference population, okay. So you multiply it and you have your standardized rates. Now you have your age adjusted death rate. How do you calculate age adjusted death rate for your final number? You have your column F, which is your standardized rates. You divide it by column E, which is your reference population. This give you your age adjusted death rate, and then finally you have your age adjusted death rate per 1000, okay, which is just multiplying it into 1000. Alright, so this number which you have, your 0.0070, this number multiplied by 1000 gives you this one. Okay, so guys, basically this is the say mathematics which is involved in the calculation of your age adjusted direct method of standardization. Okay, so if we just look at crude numbers, it shows that your country A has more number of people dying than country B, okay. But now when you have your age adjusted death rates, okay, then what do? Your age adjusted death rates basically is saying that you have say 7.09, alright, deaths per 1000, and then in your country B you have 9.59 deaths per 1000. So in country B, after adjusting for age, you have more number of deaths in country B versus country A. So you see how the interpretation only on crude number was quite false, because if you do not take age into consideration, if you do not control or adjust for age, you may just simply think that more number of people are dying in country A versus country B, and that's about it, more deaths in country A. No, but when you adjust for age, when you control for the confounding variable age, then you see that after adjusting for age, you have more number of people dying in country B which is 9.59 per thousand, compared to country A, which is 7.09 per thousand. Okay, and just for those who are interested, I have shown more of these calculations where I have broken it down for you over here. If you divide this, if you divide age adjusted death rate for country A versus country B, alright, you get a comparative mortality ratio. Again, this is just all FYI, alright, where you can basically say, you can write a statement as 1.35 per thousand higher age adjusted death rate for country B than country A. Okay, basically we are just saying the same thing. After adjusting for age, more people are dying in country B compared to country A. Okay, that's why adjustment is so important, because it may completely change the story sometimes. Alright, so as we know that, again just summarizing it, direct method of standardization, you need a reference population. Over here our reference population was C. Okay, we have a population of interest, which is A versus B. This is of our interest. If you just look at all of the crude values, you may think that country A, more people are dying than country B, but once you adjust for age, then what happens, the story changes, which is, you know that after adjusting for age, more people are dying in country B versus country A. Okay, again this is all just FYI, not for exams, not for assessments, just for your own interest and to further your knowledge in epidemiology. So now we do the same thing for indirect method of standardization. Alright, so now for indirect method of standardization, again I will be looking at my laptop. So for indirect method of standardization, guys, what was my explanation? You do this method only when you cannot do direct method of standardization, meaning when you don't have a reference population or else your sample size is really small. Let's take a hypothetical scenario where we don't have a reference population. Okay, so you have the same scenario, country A, country B, and you may think more people are dying in country A, the total number, alright, versus country B. Okay, we do not have any country C now. Okay, so there is no reference population. All this grey data is given to me. Alright, so we have our country A, we have our country B, we have population age specific death rate per thousand. Alright, so this is the population number, and then you calculate the crude death rate, B divided by C. This is exactly the same as what we did in direct method of standardization. Okay, so this is like exactly the same. This column D over here in direct method of standardization, that is completely the same as column D over here in your indirect method of standardization. Okay, so this remains completely the same. So if you see over here, I had 0.0105, over here I have 0.0105. Okay, so it's completely the same column. So you calculate your crude death rate for both of these formulas in the same manner. Then what do? You do not have a reference population, no country C. So then you calculate the expected death rate. How do you do that? You do column C into column D. What is column C? You have your total number of population for each of these age group, and then you multiply it into the crude death rate that you have calculated, and this is the answer that you get. Okay, and then for the final standardized mortality ratio, which is your age adjusted mortality ratio, what do? Is you do your B divided by E. What is B? B is your crude death rate, okay, and you divide it by E, which you recently calculated the expected death rate, and that will give you the answer over here. Okay, so this is what you do when you do not have a reference population, or else you have a population with really small numbers. In our case, we did not have a reference population over here. Okay, so again you have your age adjusted mortality rate is higher for country B, 1.608 compared to country A, which is 1. Okay, so yep, again if you go over here, and for those who are interested, if you divide your standardized mortality ratio, okay, so you have your 1.16 divided by 1. If you do this, this is the answer which you get. So basically you can write a statement as 1.60 per thousand higher age adjusted death rate for country B than country A. Okay, basically we are saying the same thing, that after adjusting for age, you have country B which has higher death rate compared to country A. Okay, so this is where adjustment is so important, and these sort of standardized rates you can compare for various population. Okay, so comparison only makes sense when you have standardized it for something. You do not compare crude rates of morbidity and mortality because they are not very meaningful. They do not tell you the complete story. Okay. So again guys, please remember that this was all just for your FYI, for your knowledge, how you have to use the information of standardization, direct and indirect method of standardization is in interpreting graphs and tables accurately. Okay, so that is where you use for your assessment, and that's where you stop. For those who are more interested in research is where I covered the Excel sheet. Excel sheet is not part of any assessment. Okay, and yep, these are the references for what I did today. And yes guys, that's it from my end, and hopefully I'll see you in the next series. Thank you.